All right, so this presentation is titled Applications of Monadic Programming. My name is Anton Antonov. Today is November 7th, 2025. This is a presentation for the Wolfram Technology Conference 2025. I'm going to be discussing monadic programming, introducing monadic programming and monadic pipelines. I'm going to use questions and answers in order to make that easier. And I'm going to use a variety of examples. Before going further, I would like to mention that I have these two screens, and I'm going to be switching. This is the screen with the presentation, and I'm going to be switching to this screen here to show some other stuff. So before, I would like to clarify a little bit that I'm a little bit beyond monadic programming. I program it, I use it a lot. I'm not enamored by it, and so you kind of please take this into account when I listen my exposition. So monadic programming is a relatively simple concept. Some people introduce it and introduce it as a very complicated concept, and I don't think it is the case. It was invented a long time ago during the Cold War. Some people think that it was given to us by aliens. And I really hope that with this question answer is kind of, informal introduction or formal, it's going to be somewhat easier to digest what it is. So this is a little bit again about my attitude. Yeah, we can monad, you can don't monad. Yeah, it's like you can live happily without knowing about monads, or you can know them, but not necessarily understand them. Again, you can probably even be happier. Maybe your life is not going to be that interesting if you don't know about monads, but yeah, that's another story. So this talk is an advertisement for a cycle of lectures, which I have started and you can find them in YouTube. So it's a more serious endeavor. Each of these lectures is around 40-45 minutes. So I'm going to start with the questions here. I'm going to stop after 10 minutes to see any other questions in the chat, in the Q&A panels. So who is this about, right? So which is the audience of this talk. So these are people who want to be informed what the software monads are. Also experienced Wolfram language or Mathematica users, monad developer wannabes, and probably other software language developers who want to know how to do or what are monads, how they look like in Wolfram language. Also, of course, these are the LLM supported programmers or code baristas. So what is a good showcase for monadic programming? So this is a scrolling presentation, and I'm going to be going up and down depending on the questions where what I want to show. So let's do a showcase. Because it's quite a long, a lot of questions and answers I have gathered. I'm not going to do that much of a live presentation, so to speak. So this is the famous Titanic data set. So here I create a certain monadic pipeline, right? So I'm starting a monad, software monad, and this software monad, I'm splitting it into 80 and 20% for the training and testing data, showing some data summary. This is what you see here. Then training nearest neighbors classifier, showing accuracy and precision and so forth. And also, when I say here, I want to see the receiver operating characteristic plots. This is what is happening here. These are the plots. Now, I can also take the actual classifier. I can take it out of the monad, and this is what it is. So I can use it for some other computations. What I'm actually showing, it's something like this, right? So we do this very often in mathematics, like say Fourier analysis. You transfer your problem into some certain other domain, in some other space. You navigate the computations in that space, and then you transfer, then you map it back, right? And so something like that is happening here. I'm taking the data set, I'm putting it into the monadic space. I'm navigating some computations there, and then I'm getting the classifier back. All right, so going back to the questions here. So how are the monads, which applications of monadic programming? Yeah, of course, very important, since this is the title of my talk. So monadic programming can be seen in from multiple perspectives. What applications mean, right? But I mean something here a little bit more conceptual and more theoretical. And so from my perspective, say as a software engineer, software architect, I might be very interested into graceful failure handling. If you're making conversational agents, for example, most of the time your system, whatever you're dealing with user input, you're failing. So you need to be gracefully failing. Another application is rapid specification of computational workflows. This is more for data scientists or data engineers. And very interesting, which is much more on probably for the software architects, but also for people who are theoretically inclined. This is the algebraic structure of the written code. And now I'm talking about the actual syntax here, the actual combination of symbols, not necessarily the objects which are the underlying objects and computations. They might be algebraic, might be not. But I'm saying that this here, this pipeline, it actually has algebraic structure. And because of this, it can be leveraged in a variety of ways. All right, so how software monads defined? Let's see, there's several kind of definitions that can be done. Let me bring one here. So I'm not going to make a live example of this, but the Unix pipeline, right? So it's, again, this is the Cold War kind of thing, what I was saying. Yeah, you can use the Unix pipeline in this way, right? And whatever computations you have, they're staged, so to speak. They go through a certain pipeline, and then you kind of modify what the output of the previous command. So I'm going to get some files which finish with the letters NB. I'm going to filter them in order to get the names which are with monad, and then I'm going to see the dates of those. Now there's a calculator called desktop calculator, again one of the oldest Unix programs, and it's using reverse Polish notation. And it's, I'm not going to expand on this, but basically, yeah, this is like very much like a monadic pipeline. And if you look at a package or system, a constellation of packages called tidyverse in the R ecosystem, they do apply this pipelines. Or it's not exactly a monad, but this is like a monadic pipeline. And you can see this is actually fairly easy to understand. We take the Titanic data, we rename some of the columns, we filter them, then group by but what we have renamed, class and sex, and then we show the counts of the corresponding rows in each group. So this is more like informal. Formally, and I'm not going to go through the formal definition, but we can define a unit operation or function and a bind operation. In some sense, probably this is I mean, if you're an experienced Mathematica user, this should be telling you a lot. So basically, you start with certain type of object which has a head M, and then your binding operation, it knows how to bind this kind of objects with whatever functions are given. If you want easy implementation, this is it, right? So you just fold with bind and right. Mathematica has always had monads, by the way, right, since version 0.01. So this can be verified using the monad laws. Again, this is like the algebraic structure of the code, which I was talking about. And this can be seen, can be verified. So you can see here with the postfix application of postfix operation, postfix function. This is the infix version of the postfix application of functions, right? We have like this kind of monadic pipeline. But the monadic pipeline I'm talking about for Mathematica from 0.01 is this, right? I mean, this is the proof here. So if your inputs are lists and the outputs are lists, you can actually prove that you have a monad. All right, so going back to the questions. So how to explain monadic pipelines in an easy to understand manner. So let me see somewhere here. Yeah, monads. I thought I had some dedicated slide for this. Let me actually go here. Yeah, this is it. So, all right. So here, right. I mean, in case you haven't understood what I'm saying, it's really just some kind of pipeline, right? There's a pipeline and you're working on the thing which this pipeline brings, right? So you basically have the pipeline and you're doing whatever kind of manipulations. This corresponds here to the classifier, right? To the classifier workflow I was showing here, right? So basically there's like a certain pipeline value. Maybe this is it's actually a context, right? It's a context with variety of things in it, but then we manipulate that context, right? We apply different operations on it. And then at some point we get to the result. I'm not sure is this better, or just more artistic, not necessarily better. All right, so what is the, how the monadic programming can be invented? Well, that's actually a very interesting question. So let me see, where's my invention of the monads. So I think it was here, no? All right, yeah. As I want, I'm going to be scrolling, and yes, this is what this slide is. This is the invention slide. Okay, so again, no, let's start with the Titanic data, and so imagine I have this natural language specification. Use DS Titanic, filter by passenger H greater than 10, group by passenger class and passenger sex, counts, right? Or show counts. Now, these are different codes, which is, you can see actually there's some function here, some packlet, which actually makes this translation from natural language to code. But I can see, for example, in Python and Wolfram language, how we have these assignments here, right? So after the first line, you see object, it's on the left-hand side, but also it's on the right-hand side. And we might ask, especially here, right? And especially, I don't know, like you can see it also here. Maybe that's not needed. Maybe you can stage your computations, you can define your functions in such a way that you don't need to have this assignment, right? And so, and this is more or less what is happening here with this R code, right? So this again from type diverse, it's a package dplyr, right? And yeah, I mean, so we take Titanic, we filter it, we group it, show the counts. This is actually this kind of reduction of the syntax sugar can be enough of a motivation, but it also has some kind of further implications. And so this here is just showing the different computational examples. All right, so let me go to the questions, which I'm scrolling here. How to explain monads in the easily understandable? We moved through that. Is knowing monadic programming required? No, I mentioned this. I'm going to mention this again, right? So you can live happily without knowing about monads, right? Now, monads, depending what you're trying to do, I mean, what is your goal for knowing or utilizing them? I use them mostly as a user interface. And from that perspective, they serve very well. But in some languages, like if you program in Haskell, even if you don't know what monad exactly is, monads are being used to actually, develop the language, conceptually. And so since and I answered this question, is monadic programming supported in a Wolfram language? Let me look at the questions here. Okay. I see in the Q&A section, very basic question. Can you explain yes, can you explain the double right arrow symbol that you often use in your presentations? I'm not familiar with it and Wolfram syntax. So basically, and this is related to how monads are programmed, right? So I was saying that monads are programmed in a very easy manner. You just fold in this, right? And to some extent, this is what is happening. So if I kind of go here, let me see. I'm simply overloading. It's like an algebraic operation. This is like one of the operators which you can overload. And so basically, I'm saying, if you see this double right arrow, this is going to be expanded into some application of fold, right? So whatever we're showing here with fold, yeah, it's just that. So it is it's a little bit more than that. But if you are really curious how this is done, there is a package called monad makers. This monad makers is used into, you can see I have a bunch of monadic packages, in the Packlet repository. Basically, every conference, Wolfram Technology Conference, I submit 1 or 2 packlets before the conference, and this is the case for this package, Event Records Transformation, which helps managing time series, and this is DSL examples, which actually can be used to use LLMs to translate commands. And you can see if you translate this way, like if you lose this pipeline segment, right? It's you see. I use the LLMs to translate command by command, whatever the specification is, and then I just concatenate them with this double right arrow. Now, the double right arrow, when you kind of have this whole expression here, let me zoom. When you have this whole expression, it's just converted to fold, right? And this is many of my packlets internally very often because the syntax highlighting, they don't understand necessarily the application of the double right arrow. I actually use the fold. I implemented it with fold because it's kind of more clear and supported by the corresponding highlighting software modules. All right, so hopefully I answered this. Let's actually go back to the questions and see, right, what else? Is monadic programming supported in Wolfram language? I already explained this, but again, I would like to mention this. At some point, like a few years ago, or 10, people were like, hey, when Mathematica is going to support monads? Well, always has supported monads. Obviously, Mathematica is a big language, and not necessarily everybody knows all properties in it, but this is actually fundamental in some sense, right? And it is somewhat fundamental to Lisp-like programming languages. So, okay, what are the limitations of programming using software monads? This is an interesting question from a conceptual perspective. So, it is do people think in a linear manner, right? Somebody might tell me, no, we don't necessarily use thinking monadic pipelines. Well, I don't know. In my experience, most people, especially nowadays, right, they don't necessarily want to program, right? They program, but it's inflicted on them. They're basically doing, I don't know, like say data science, engineering, whatever, right? And then they kind of rely on recipes. And they'll rely on this kind of simple staged type of workflows. And another thing here, one of the easiest things to automate with machine learning is machine learning workflows. And you can see it here, right? So you can see how this machine learning workflow here, it's pretty well pipelined. Now, there's certain situations in which, if you're using Wolfram language to express some kind of ideas which were not even clarified, in your head, and you're using programming in order to understand and clarify better what is going on, right? Well, there's no pipelining per se, although you can use like the monads as an interface, the interface perspective as a brainstorming technique. Okay, so. Yeah, and this is what I was saying. If you want to use the monads as a software interface, actually, it's not, say in Wolfram language. This actually means that you have to do quite a lot of work. Let me actually show you this. So I'm going to go to this Packlet, and the Packlet has a GitHub link. And I'm going to go through the code of the Packlet. And so, yeah, so you can see it's actually, this is not necessarily that elegant or that concise. Right? In some sense, I'm doing quite a lot of definitions in order to have this kind of nice pipeline behavior, handle errors gracefully and so forth, right? So, and you can see also, like, if I go to the beginning of this package, somewhere here, the actual monad, the core of the monad is being generated using this monad makers, which are, okay, so just a moment here. All right, yeah. So I have, so these are generate state monad code, right? This comes from this Packlet monad makers, which I was mentioning earlier. And I'm saying, well, this is how my monad is supposed to be. What is the prefix symbol? and some of the elements of it, what are the context of that monad, and then then I'm basically implementing different operations, right, in the monadic space. And so, and these are functions which can be pipelined. So it's very similar to, say, the add star operator, right? Like, say, if I do, okay, maybe not here, but if I do something like, I don't know, like, say, identity, maybe like this, and then sign, and then X, right? So, I mean, it's somewhat like that, in a sense, like, you see, this is an operation between two functions. So I know big part of it is that. Now, is that easy to do in Mathematica? Yeah, definitely. In Wolfram language, you can do this relatively easily, but you need to spend the time testing the software monads and kind of seeing do they actually produce the experience? Do they actually handle gracefully what you're doing? One interesting way to do it actually is to generate random pipelines. And this is another thing which you can do easily with this monadic perspective. I mean, imagine that I know that in a pipeline, I might say it has, like, say, 5 or 6 elements, or between 3 and 6. I can generate the segments randomly. I can put them together, and basically I either should get the failure symbol, failure symbol of the monad, or I should get some result, for example, right? And this is how these Packlets, how they have been tested, right? I have like some special kind of packages about this, and I probably kind of spent too much time on this, but okay, let me, since I started answering that question in that way, let me see where it is here. So I'm going to go to my GitHub repository. Initially, before the Packlet repository was established, created, I had this in a separate part here. And one of the things here, well, maybe it's in unit tests, right? Yeah. So let Monadic unit tests. Somewhere here, you might see these are actually. This is not the random generation, but I guess you have to believe me. I thought I can find this very easily. Anyway, somewhere here, I do have, like, say, okay, yeah, I do have it, right? Random pipelines, right? So I'm generating a bunch of, like, say, 300, 400 random pipelines, and I'm actually testing, do I get results which I expect. This has been actually a very good way to stress test the system. And yeah, you can see here, these are the different stages at which I'm selecting the segments, and then I'm kind of, making the random pipelines, and then I run them. All right, so I'm not going to, let me kind of return to here. I have only a few questions more to answer. And yes, so why do I use monadic programming? This is actually a big question, and I'm going to just scroll down and find the visual aid. This one here. So let me see. Should I slightly, at least, maybe zoom out? Okay. So there's a certain problem domain, right? I or whoever we develop a software monad for it. Software monad for it. This is a package or Packlet or whatever, and then we in parallel we develop certain domain specific language of commands which actually clarifies what exactly we're trying to do. And I mean, in a sense, like, you should be able to formulate the operations in order to, if you understand at all what this problem domain, you're trying to get to internalize, or you're trying to understand, or, make tools for. And this is an iterative process, right? So you make these monads, you make these DSLs, and etc., right? At some point, unit testing for the parsers, for the grammars, at some point you marry the two, and you can make a conversational agent for that. And so this here, maybe this is live. Let me actually do a live evaluation here. So basically what is happening right now, this ARS, right? It's a bunch of, it's basically, for each of these commands here, I have generated the pipelines, right? And this table you see here it has this kind of pipelines. Another thing to kind of do is, let me actually, this is related, but you see, for example, this pipeline here, which is with the again classification, I can actually do it, say, with LLMs in this way. And this is related to what I was saying. I have some grammar, or I have some commands which I have developed, and I can evaluate this. I mean, like what I'm doing right now. I think I'm evaluating. Yeah. So each of these commands right now is being translated by an LLM. And I claim, or I hope, that this is actually going to produce an executable code. That's actually not at random at all, in a sense. I mean, I know to be guaranteed, if I evaluate this in place, you see, I called an LLM, the LLM translated this in place into that command, right? Or if I do show classify measurements, this actually is going to be yeah, it's supposed to be somewhat more complicated. This is related to this algebraic properties of the monadic code, right? I can plug and play different elements of this pipeline, right, and make more complicated pipelines. So, so basically, I would say, I mean, this is one of the ways to answer it. I had some other kind of example here. Now, why I'm using monads? I'm still answering why I'm using monads. So you can see this here. This okay. For some reason, I cannot copy this. So let me show you this here, right? Now this here is a monadic pipeline which doesn't avoid the monads, right, for doing quantile regression. And I can request code generation with avoiding the monads. Very often people tell me, well, I don't want to use your packlets. Give me just, mathematical code with whatever kind of tools I have which do code generation. Yeah, this is the mathematical code for it, and you can see it's actually quite messy. It's doing exactly the same thing. I mean, if I evaluate this code, it's going to produce, it's going to produce more or less the same results as this one, right? But like which one is more convenient or easier to see? I mean, you can see it here. It's taking the data, giving the summary, doing the regression, doing the plot. Yes, you can find the corresponding elements here. It's just messy. All right, so I think I have one or two questions more I wanted to answer. Let me kind of see here. Maybe I think I answered the most important ones. Well, yeah, I mean, yeah, I've been developing software monads in Wolfram language more or less since year 2017. I was teaching a class for digital humanities in Oxford. And at the time, this is before the LLM revolution, right? So at the time, it was kind of obvious. These digital humanities students or graduate students, they could understand the workflows, but because of the too much code, you need to kind of go through and understand. It need to be basically a fairly developed programmer. It was very hard for them to do anything related to data science. Now, this is not necessarily the case. All right, I mean, you can do, I mean, with LLMs, with this kind of systems like what I'm showing, this can be very easily done. All right, so I think I mentioned everything here I wanted to do. There are quite a lot of references in this notebook. Where also every section, it has its own kind of its own references, and you can see some topics I didn't talk about. But yes, this doesn't need to be about machine learning. It can be about epidemiological systems. And another thing is that, yeah, it can be nonlinear. We can have some very nonlinear, non-pipelinable type of monads, and this is one of the examples of this is using functional parsers. All right, so let me see any questions here. I don't see any kind of questions. So yeah, let me then for the rest 1 minute explain. So you can see these algebraic operations: circle plus, circle multiply, and circle dot, right? And I'm using those to kind of make some kind of complicated parsers. But these parsers, each of these are functions. So basically, this here, it's a very complicated algebraic expression between functions. So this is another way to kind of show why monads are being used. See another question here. Is the presentation notebook available? Oh yeah, I'll upload it immediately after this. All right. So I don't see any other questions. So feel free to contact me after the presentation. Guess that's it. Well, thank you for your attention.